guess good afternoon, everyone. It's 22, so I'm going to start. I do apologize, having watched the previous presentation, I did not include any interactivity in my presentation. So I guess I should just ask, is there anyone here who wants to be a data scientist? Like, no hands. Good choice, good choice. Right. All right, so I'm Neil. I'm a data engineer at Equal Experts. I'm actually a recovering data scientist. In the next 30 minutes or so, I'm hopefully going to convince you that if you do actually want to be a data scientist, you should be building models, web apps for your models. If time goes well, I also have a very, very simple demo at the end. So I don't know how familiar you are with transformers. They're basically a natural language processing model. The first Transformers paper came out in 2017. It was followed by BERT, a big model from Google. Was then a year later, 2018. Still 2 years after that, in 2020, which is what's up there, was GPT-3, right? We get paid to mention this, but ChatGPT, which I'm pretty sure you've heard enough of over the course of the day, is built on top of GPT-3, right? ChatGPT, you obviously know, came out just a few months or end of last year. What it was built on was 3 years ago, right? So my question is, what is it that made ChatGPT the success that it is, right? And I'm going to tell you, it's because they had a web app, right? This technology has been around for many years, but the reason why everyone and even your mother on Facebook knows about ChatGPT is because there's a web app you can use, right? None of this previous tech, I mean, you had to download code and run pickle files and build things in order for you to use it. So, I mean, you also have the option of making a whole movie out of your paper. I mean, each to their own. It's a bit extreme, but do watch this. It is a good movie, right? So now, when you're building a model, you're obviously going to start with, going through your data, doing your histograms, looking at your summary statistics, doing the usual things. You can actually build a web app for this, by the way. Once you've actually built your model, you're going to do things like confusion matrices and look at things like recall and accuracy and so on, right? Also, no one started the timer, so I'm just going to have to trust someone's going to raise a hand. These are all just standard processes, right, of how to actually build a model, a machine learning model. What you will also do is, say you wish to properly evaluate your model, those summary statistics that you're looking at, right, that I mentioned about precision and recall, accuracy, whatever you're going to choose, are all like global metrics that you're looking at for your model. If you really wanted to sit at your desk for 3 days and pretend you know what you're doing, build a decision tree and print it out and just stare at it, right? Everyone will think you're being super fancy, even though it actually doesn't really mean much, right? What I want to convince you is obviously to build a web app, right? And let this web app be your final step in your model evaluation. You've investigated your data, interrogated your model, you've done all these things statistically, right? Accuracy measures are done globally, right? But when you build a web app, you're basically going to be looking at your model, how your user will be using your model, right? Because your user doesn't care globally or statistically what your recall is. They're looking at individual cases of your model, right? So a really great example, there's many data sets out there, right? So let's pick one. It's called the California housing data price, right? Where the goal is you have a whole bunch of metrics, the density of the housing, number of rooms, bathrooms, whatever, and it's correlated with, or you need to predict the price of the house, right? Now you can go out, build your model, pick whatever you want. But when this model actually gets consumed, right, no one's going to be like, oh my God, I love your pickle file and your accuracy is 90%, right? This person is going to be a house buyer or a house seller. They want to know, if they're a buyer, they want to know about the house that they are looking at. What is its value, right? Because they want to know if they have a bargain or not. Likewise, if someone is selling, they have a specific house in mind, right, that they wish to price for the market, right? That is an individual basis. The accuracy and your root, mean, square errors, whatever you want to pick for that particular person, it doesn't matter in that instance, right? Because it's a single case of something that they're looking at. And this is what will allow you, in building your web app, and I'll show you examples to go through, is what's going to allow you to basically interrogate your model and build your intuition around your model the same way that a consumer of your model is going to use it, all right? So, again, I'd already told you none of this is possible if you just have a Jupyter notebook and a pickle file sitting around, right? Another option, or another, I suppose, facet of building a web app. Let's imagine you work in a call center, or you don't work in a call center. You know people who work in a call center. And you've built this model where you need to analyze leads, right? So it's who is most likely to either pick up the phone or buy the product that the call center is selling, right? You've got two approaches to do this. The first approach, assuming now we have this web app capability, is to do something like you build your model, you build your web app, you send it off to the call center gets someone they need to call, they plug in the information into the web app, click evaluate, and the score will come to 80, 90, 10, or whatever, and then that call center agent will then decide, hey, should I call this person or not, right? So there you've actually, like, let's air quote, productionized your model. That's a terrible approach, right? Don't do that, right? The call center agent should not be scoring who they should call, right? In that situation, you're going to take, here's a list of all the leads, push them through a batch process, and only send the call center who they should be calling, right? Because a call center agent does not have the time to play with your model, right? They're going to go through thousands of people a day, or hundreds, tens of hundreds, it's who knows, right? They want to get through. So, yes, I'm telling you to build a web app, but be aware of the situation, right? It's not going to be fitting for everyone everywhere. Some of you may be thinking like, oh, hey, I mean, none of you said you were data scientists in this, when I asked you to raise your hands, but for those of you who know data scientists, right, we'll say things like, oh, hey, like, batch file is totally how we do it. I just build this pickle file, I send it off to people, and they turn it into an API and do things, right? They wave their hands and they say things like MLOps, right? Which, incidentally, speaking of MLOps, there's actually a workshop after this, right? Downstairs in the exhibition center, which I do suggest you all go to, right? Anyway, so I'm really glad your model gets turned into an API. Good for you. But the people who sign that off, the people who are like, yes, your model works, let's send those leads to the call center, I'm willing to bet that they do not care what your accuracy is or do not know what a confusion matrix is, right? Mostly because they probably got promoted based on just time at a desk, right? And let's be honest, no one is going to know who you are as a data scientist if you don't give them things that have buttons and sliders and things that go pop and change, just like these stupid BI dashboards, right? The reason why these are popular is because people can play with them, right? They can be like, oh, look at my quarterly sales, right? Watch me change the quarter, right? So for your own professional development, please give the people that pay you something to play with, right? Because they do not know what a pickle file is, they do not know what an API is, and they do not know what a Jupyter notebook is, right? If they do good for you, that's great, stay there, right? Anyway, another reason to build a web app, again, our previous presentation, if you were here, went through 5 whys. So I'm going to do something similar and give you 5 whys as to why you should do this. Is it gives you a structured way to think about the inputs for your model, right? Again, as a data scientist, you're just like, oh, this is my data set, I built my model, right? But as soon as you put it in front of someone, and even if you're a developer, you know this, they are going to put things into your model that you never thought a human could think of to put into your model, right? And so when you look at the UI elements that are available, you have to say to yourself, okay, remember, we're building a web app, right? And so for our California housing prices, we need to say how many rooms there are, right? So the question is, well, is that a drop-down, right? Can I list the 1 to 20, but Can houses be continuous? Rooms, can I say 2.1? Is it just 20? Is it going to be a slider? Is there a minimum? Is there a maximum, right? All of this is you validating what the input to your model will be, right? Yes, you are thinking about it in terms of a web app, and because there's only a finite number of UI elements that you will hopefully become familiar with, you can sort of restrict the options and say, let's fix it to just this possibility, right? This is helpful not just for building your web app, but when you hand it over to Billy the ML Ops kid, he's going to ask you these same questions because he is going to have to validate the input for your model, right? He's going to do that on your behalf, hopefully, fingers crossed, right? He's not going to say to you, is this a slider or is this a drop down, right? He's going to ask you things like, what's a valid range? Is the number an integer? Can it be a float, right? What's the min? What's the max? These questions, hopefully, you would have already answered because you built yourself a web app, right? And you essentially use these UI elements to validate your input. I mean, that's the idea, I guess. The last reason is, build a web app because everyone's already doing it, right? This isn't novel, it's not new, it's been around, right? People are doing this, and if you don't, you're going to be left behind, right? Also, when you go and start looking, hopefully after this, at the examples that are out there, build a web app because they're just freaking cool, bro. Like, the things that people are doing are truly amazing. So, hopefully up until this point, I've convinced you why you should be doing this. The next part is going to be how, right? If you want to do start from an HTML file web dev, right? Which, I mean, some people do choose to live their lives like that. I wouldn't. There's Fast API, Flask, D3 is a JavaScript library, really great for doing fancy graphs and things, and right? There's PyLint, right, which is the pi little angle brackets there, which is a new product where you can basically run Python in the browser, right? So if you know Python, well, guess what? You can do web dev, right? I assure you it's really not that complicated if you keep it simple, right? We're not going to look at any of this. This is way too complicated for what we want to do. These are the libraries you should be using, right? It all started with the OG Shiny for R, right? The Shiny for R, the R people, I should say, brought us Shiny for Python, because even the R developers knew you shouldn't be using R, right? There's obviously Jupyter. By Jupyter, I mean Jupyter Notebooks with widgets, right? If you didn't know, you could install widgets in Jupyter Notebooks. Congrats, you know now, right? There's Dash, which is by the Plotly guys. Plotly is like interactive plots, and then they've obviously built Dash on top of that to give you sliders and stuff. The two big ones are Gradio and Streamlined. Gradio was recently bought by Hugging Face. If you know Hugging Face, then you know how great Gradio is. Hugging Face is basically a whole bunch of like community-driven ML models, and they've also got really great APIs and things to try on the website. And then obviously Streamlined, right? Streamlined was bought by Snowflake. If you've heard of Snowflake, I mean, you got a little bit, tingly inside. You may actually be a data engineer, right? In that case, you should email me your CV, because then I will forward it to our HR team, and hopefully I get a referral bonus, right? I'll put up my email at the end. And then, I think we're doing really great for time. If I've gone through this too quickly, I apologize. Let's do a demo. Let's look at hopefully the dumbest demo you've seen today. Maybe I should also just say, so Streamlit, really great docs, right? There's also a really great gallery that shows you, I can't see with the mic in the way, of what people have done. Please go have a look, they're really great. And then for the sake of completeness, I had to show you Shiny for R, the original. Obviously, don't use any of this. It's R. We don't like R, right? But do have a look at the examples and stuff that's there for inspiration, right? Let me just quickly go to what I wanted to show you. So firstly, I've built a model. It's a terrible model, right? If you cannot see what's wrong with it, please don't be a data scientist, all right? And here's my web app, and it literally just starts with importing Streamlined, right? Streamlined has its own classes, blah, blah, stuff, like st.title, obviously displays a title. I should probably show you the app here, right? So here's our house prediction model, and there's the house prediction model that produced it, right? And what it basically does is when it runs, it will, let's pretend, yes? Oh, yes, I can do that. How's that? Okay, maybe we can go one more. In essence, what it does is it will just constantly evaluate this Python script, right? So every time something changes, so if I drag a little slider, right, it's going to say, register there's been a change on the front end, and it will run the script, right? It obviously does clever caching things in the back. So for instance, you can see here I'm loading the model. It's not going to reload that model with each run, right? How Streamlit does it doesn't matter. That we don't care about that, right? None of us are going to be Streamlit devs. So you can see here I am fetching my data model, my data set, right? I'm then loading the model, my brilliant model that I built, right? And then this is just to show you that because Streamlit reruns this app, the script every time, it doesn't store state in between runs, right? So if I wanted to generate a value, make a UI change, and still have access to that value, I need to store it somewhere, right? And this is where Streamlit has this notion of a session state, right? Which is what we're abusing here. The idea here is that when I click this random sample button, it's going to go into my data set, pull out a random sample, and basically set all the sliders to be that value, right? The thinking here is, given the ranges in all of these values, the possible universe of slider values far exceeds the actual data, right? So if I just randomly change these sliders, I'm going to be exploring house models or house values that don't actually, probably will never exist because they're just outside my data sets, right? I'm doing a terrible job at explaining that. Just be like, yeah, that makes sense. Okay. And then obviously each input is going to have its slider. So here's my median income slider. Given it a name, given it a value. This is where those randoms come in, right? So this is the initial value that it gets set to. And then I'm picking a min and a max for the range because it's obviously a slider. And here you can give a callback function to say, oh, hey, when the slider changes, do something, right? Here I'm simply saying do nothing, right? Because the values are used at the end. If we use the lessons I've hopefully imparted you from my very brief presentation, you can already see here I'm saying the min and the max of the data set, all right? Is going to be the min and the max of my inputs. We should be asking ourselves, does that make sense, right? Should it be the min and the max? I could clip it, right? I could make it smaller. I could say, because if you look at the value of 0.5, does that make sense as a minimum? Could it be 0, right? What would it mean to sell a house if the median income in that area is 0, right? Do we want to restrict ourselves and say we only want to focus on areas where the median income is between this and this, right? Can the median income go up to 100, 1,000, right? I mean, we haven't seen any of that in our data, but what if our model can project beyond what's in our data, right? And so answering these questions is going to help you to develop, I think, a better intuition about your model. And again, these are questions you will need to tell whoever is going to productionize your model because they will have to validate these inputs, right? If someone goes and types in 1 million, if you never validated that, how would you know your model would survive, right? Also at this stage, sorry, if anyone has any questions, just raise your hand if I can see. So what else did I want to show you? I wanted to say so when you evaluate your model, globally you say here's an unseen data set, I'm going to put it through, get my accuracy. What you can't do is, or what people, I should say, don't typically do, is generate values that aren't part of the data set. So here I've drastically decreased the income, the median house age, and increased the average rooms. Right? So I'm saying this is a very low income area with small houses that have big rooms, right? Not exactly realistic, but we end up getting a negative value. We should be like, oh, hey, something's wrong, right? This doesn't make sense, right? I'm willing to bet that if you just looked at an unseen data set, you wouldn't have picked this up, right? But I assure you that there is a buyer out there, if you had just released this model into the wild, who would have filled in these values, got a negative answer, and been like, I don't know what that means, right? So yeah, and then, one thing I didn't actually show you is where the magic happens, which is if we scroll right to the end, here I'm simply just loading up the house features, right? So I'm saying like, put it all in an array, predict it, and print it out, right? Literally nothing special, and that's exactly what you're seeing down at the bottom, right? And yeah, that's it. Does anyone have any questions? Sorry, I do feel like I went through this very quickly. Oh, yes.
So I've got 2 questions. One being procedures, and have you heard of dark mode?
Okay, so I'll just repeat the question. Have I heard of dark mode? I mean, clearly not, right?
The second question is that I can see that the value having what I would call like a UAT tool that you give or hand over to the integration. But what other purpose would it serve in DSLC? Like where would you start this in? Like where else do you see this starting in the DSLCs?
STLC.
Sorry.
Like I said, recovering data scientist, right? I don't know. I really don't know. So like, where does this fit in? The premise of my talk is that every data scientist I've interacted with, right, has done really great work, and it's sat in a pickle file, or it's a batch job, right? It's the kippie with the Power BI dashboards that gets to present and gets all the praise. Why? Because there's colors, and there's sliders, and there's drop-downs, right? My premise is simply saying, if you are a data scientist, you should be doing exactly the same thing, right? This product is not going to be integrated, and it's not going to be, you shouldn't aim for your web app, especially if you are currently a production-worthy data scientist, to be deployed company-wide, right? It's okay for this to run on my machine. This is for you to demonstrate your work, I think, is the very simplest answer, right? If you wanted this to be deployed company-wide, it then becomes more difficult because then it now has to be productionized, you need to have failover, you need to have passwords, it needs to be logging, right? None of that stuff, you're going to be doing and should be doing as a data scientist, right? Also, let's be honest, if your company wants to roll this out, it's probably going to be integrated with SharePoint or something stupid, right? So, right? Yes, question.
I've got a Streamlined question.
Yeah.
Are you saying it's not some clever caching? Because I've always seen, I've seen popularity on the web, but I steered away from it because of the execution model and not things like Dash or Pinecone. But he's saying it actually does clever things like moving, so you don't feel the pain of rewriting.
Yes. So the question is, the caching in the background, right? Is it there? Yes, it is there. I mean, don't ask me on the exact details. I don't know. All I know is it's smarter than me, all right? And that diffing is both in terms of when the script loads to say, oh, hey, I already have, I've already loaded this file, don't reload it again. And in front of the render on the front is also got its own diffing, all right? So it says, hey, only this element has changed, I'm not going to change the rest, right? And this is a combination of both Streamlit being clever and modern browsers actually getting far more credit than I think they deserve in some ways, right? Again, go and have a look and see what other people have built, right? And they've truly like pushed the limits of what you would think is even possible with having a little script in the background, right? Yes.
You share some of the tools to build some of these web apps. Like, are there any other tools that you can recommend to actually deploy this to be able to share with the call center? The experience of running models can be very expensive. Are there any other tools that makes that whole process easier?
Specifically for, okay, so the question is any tools to deploy these models, right? I don't know. Kubernetes, right? That's popular. No, it is just a web app, right? If you're not worried about things like authentication and logging and, I assure you, you will get pretty far if this little script runs on a desktop under someone's desk, right? I can say that because don't tell anyone I've done that, right? But I mean, if you wanted to deploy far more productionized things, there's other tools out there. Now that I'm standing in front of all of you, I cannot remember any of their names. But Azure, Azure ML, there we go. Can't go wrong with Microsoft, right? Any more questions? No, great. Well then, thank you so. Oh, you know what I didn't do was I didn't put up my email. How am I supposed to get a referral bonus if you can't send me CVs? All right, maybe I should have done that. Yes, there was a hand.
For Alice, you're a data engineer now, and now I presume, like, compared to some of the data engineers I know, that they're producing a lot of these data sets. What tools do you use for data exploration or visualization for the data that you produce in your, yeah.
Okay, so you can build a web app to explore your data. Right? Streamlined is really great for that. There's a talk going on, you might be a bit late. But no, literally matplotlib. If your data is already in something like Snowflake, which is really great, you can build dashboards in Snowflake to look at your data. Also, like, it doesn't matter. Just draw a graph, right? Like, go to Google and say top 10 libraries to draw graphs, right? Like, find one, try it, play with it, find your favorite, right? Go to DevConf. Come to my talk next year, Al. No. Yeah, question. It's a wonderful QA session, yes.
There seems to be a bit of overlap between the data engineer role and the scientist roles. What would you say are the key differences?
Oh my God, okay. Key differences between data scientist and data engineer. Well, one is a scientist and one's an engineer. No, I think they are drastically different. And I think, now that I'm being put on the spot, I would say one curates the data and one uses the data, right? The primary focus of a data engineer is to make sure that your CSV files get loaded successfully, all right? Like, let's be simple about it. And your data scientist is to take those CSV files and turn them into a model, all right? I mean, don't quote me on that. I've literally just come up with that, right? Any more questions? I mean, or JSON files, right? It's like, or Parquet. Right? We could also do a whole talk on file types if you want. Any more questions? Let's just open the floor, whatever you want to ask. No? Okay, cool. Well, thank you so much. Have a good afternoon. And oh, wait, well, last question, yes.
Yeah, if you ask people to come to the MLOps workshop, what's MLOps and how is it different from DevOps or Dev?
Oh my God, okay. So the ops is the same, right? Whether it's ML or DevOps. Here it is just specifically of how to deploy a machine learning model. In DevOps, when you deploy, you have a bunch of unit tests you can run to say whether or not that deployment should be promoted to production. When you deploy a machine learning model, you can't run unit tests, right? There's no real concept of a unit test for a machine learning model. So the question is, well, then what do you do, right? Do you retrain the model? Do you keep data sets aside to evaluate the model against that? Do you have thresholds for your accuracy if that's the metric that you've chosen? So an approach is to say in MLOps, hey, here's a model, only deploy if my accuracy is above this, right? Is what, again, being put on the spot, I would say the difference is. Or you could attend the workshop and find out, right? Okay, thank you so much.